So, welcome everyone to this session. This session is about identity management in campuses and services. And our first speaker is Candido Rodriguez from Red Iris. And the first speak is about integration of LDAP directories and web services and CLDAP. I wonder how you pronounce that in English.
Yeah, CLDAP.
CLDAP, yeah. Please. 25 minutes and 5 minutes for questions.
Okay, thank you. I'm going to talk about the CLDAP project and how it makes easy interaction with directories. It's a project that we started in Red Iris the last year. This is the summary for my presentation. First, I'm going to talk about the goals of the project, and then the description of the API that we are developing in this project. And we see a demo of a client using that API. Also, I want to present you the COPA technology for making virtual views in a directory. And we've developed also another demo using that technology. And I want to talk about a new future standard named XLDAP and how it affects our project. Okay, goals. First, we want an advanced browser administrator of LDAPs. Why? Because we don't feel very comfortable with the tools that we find, like GQ or PHP LDAP admin, because the usability of that tools are very poor. So we want another one and better. And also we want that that new tool understand the typical schema that we usually work in our environment. For example, COPA or a schema published by Red Iris, and in the future SHAC. And also we want a web.0 application because I think it increased the usability of the tool. So for this purpose, we are developing an API through web service. So it can be possible a communication between the web application and LDAP, because at this time there is no API for that purpose. And also a wiki about LDAP, because in Spain a lot of people don't understand very well English, and learning LDAP is a bit difficult. So also we want to open a Spanish wiki. This is the URL of the project. You can find in the Forja of Red Iris. It's like a SourceForge, but a national project. So the description of the API, they are a set of functions that they are not only basic operation, but also they are complex operation. And we don't want to implement those complex operations in every application. We want to develop one time, and all the applications could use them. Okay, so they can be called from a variety of platform language, Java, Python, PHP, whatever you want. So how we resolve this problem? Using REST and web service, because all applications can understand XML, okay? Also, REST is the most simple, so it's a great news for us. And we can resolve the problem of integrate Ajax technology with LDAP. But maybe in the future, there will be available more protocols like SOAP, JSON, XML RPC. Maybe if there is any group of developers that they need it. So how is a request in the API of CLDAP? The request in the REST interface is only an HTTP request with a GET method or a POST method. It's very easy. But we have a problem. There is no formal specification of how should be made the request. So we have always read the documentation and see which params are expected and which values and which format. So, for example, for performing research in LDAP using this API, the documentation says that it's an HTTP request using get method, and there is a mandatory parameters that is the DM base, and there is some optional parameters, and we only have to make a connection to an URL like that. It's very easy. It's like only very easy, very easy. And how is the response? It's only an XML message, but we have the same problem. We don't have any formal specification for the response, so we have to read the documentation and see what's the expected elements in that message. So for the last request, this is a typical response. We have a list of entry that they have a list of attribute, and they have a list of attribute value. In the future, we want to resolve the problem of the formal specification using XS schema, but we are working in that. So right now, what functions are available at this time? Well, for basic operation, we can get an entry and the information of that entry, performing searches, add, modify, replace, delete. Okay, those are very basic. It's very typical. But also we want import and export in LDIF. That's a good idea. And also queries to the schema, so we can check which object classes are available and which attributes they need. So this is the most basic operation that we can do at this time. Also, with developers, some helper operation, because, for example, a web application cannot get the photo directly from the LDAP. So we've made some web service to get an image and to get a certificate and make so you can link from a IMG tag, okay? And for the certificate the same. So I want to show you a demo because it's the best way to see the powerful of this API. The demo is very simple. It's only the first client developed 100% in HTML and JavaScript, and it only uses the web service for the communication with the LDAP, and it's very, very easy. So as you see, the client send a HTTP request and receive XML message from the web server, from the web services, and the web service connect using the PHP API, because the web services are developed in PHP. They connect with the LDAP server. So I want to show you a browser, a simple browser of the Red Iris LDAP. Maybe this one. Good. Configuration. Obviously, for the web service, we have to define where is the LDAP server, the port, the user. So this is the Red Iris LDAP, and this is all entries in the root level, but the children of the root level. And for example, if we can change to English, because I don't want Spanish for you, and there is no new request. It's 100% Ajax technology. And for example, looking for someone who has a photo. Ajay, maybe you recognize this man. He's working in Red Iris. No, but as you see, there is no new HTTP request, so I think it's very cool. And if we can see the code. It's only 1 minute. Trying or playing. For example, the HTML code is only that, and the JavaScript code is only that. With the few lines of code, you have a full browser of LDAP. I think it's beautiful. Well. Come on, intern. So, the main goal, I think, is to use complex technology with LDAP. So, we want to show the technology COPA, because we've developed it in Red Iris, and they allow you to make virtual views in an LDAP. So, what's COPA? It's a coding schema that allows effective searches in hierarchical structure. What's that? Well, you have some codes, and you can make a tree structure with those codes, okay? But for that, you need to define some elements. First, classification. What's that? It's a set of area in a tree structure, okay, using alphanumeric code, and also you can make relationships between some different areas, okay? And what's that? Okay. For example, you have 3 entries at the same level that they have different COPA code, okay? A1, A2, and A1, B1. As you can guess, A1, B1 means that it's the first child of the entry that has the A1 code, okay? So using a plain structure, you can make some virtual views, some tree structures, okay? And also you have to set which elements in the LDAP are associated to different areas of a classification. So we can create virtual views over an LDAP server. This is the final result. So you have your typical LDAP, I hope with a plain structure, and you can add some areas, and then with some magic defining some attributes in the resource, in the element that you can make a relationship between them and the areas, you can make a new virtual view. But you don't change anything in your LDAP. You don't change your structure, okay? That's important. And at the beginning of this year, we published the second version of COPA, because we see that it was very complicated to make a client that navigates automatically by the classification. So we define some new object classes that you can read later with some relax. But I can show you an example of what you can do. So you have to define the entry that you want to start a new virtual view. In this case, dc equal unif, comma dc equal s. So in the attribute COPA def nav, you define the entry that it has the configuration of the new virtual view. In this case, well, you can see dc equal unif we. In that entry, you have to define all the configuration of the virtual view. The prefix of the URN, that because the relationship between resource and area are made by URN, the name of the virtual view, the attributes that contains the COPA code and the name of the area, and where is located the areas. An area is very simple. It's only the name, a description, and the COPA code. So at this time, what operation you can find in the API of CLDAP? Well, we have a full set of functions for navigate, not for administration. So I hope during the summer we can publish the new version, and you can administrate your LDAP using COPA code. But you can see that you can get a list of available virtual views, a list of area, a list of resources that are associated to a specific area of a specific virtual view. And I want to show you that that's true. That's running now. So there is another demo that I installed a local LDAP in my computer with a generic LDAP information of a university. And I have to change the configuration of the API. This is the same browser, but using COPA technology. So I put in English, and I'm sorry about the name of the area that they are in Spanish, but you can understand the technology, because for the virtual view called Catre, you can find 5 areas, and you can go to the first one, for example, and then the biology, that it's A1B1. And you can see that there is a resource associated to this area. So we can go to that area, set to that resource. And if you see the DN is DC equal this1, comma, DC equals unif, comma, DC equals S. They are stored, it is a child of the root entry, but we're navigating in another structure, and we don't modify anything. And we can see it's a very, very plain LDAP, and this is not the structure that we are navigating before. So that's cool. There is no photo here, sorry. And what's about XLDAP? Well, this is a new draft published by the IETF with the main goal to work with LDAP using XML message. It can be the same that we are doing, but it's not the same, because they only mapped the LDAP version 3 protocol to XML message. It has a very big problem. You can see this is the request. It's impossible to work with that, and it isn't an easy task. So we think that it's too complex for integrating with Ajax. It's not the best solution. So we only work with XLDAP when there be any XLDAP client available. At this time, there is no one. Maybe in the future. So this is all my information about CLDAP. Any question?
A couple of years ago, there has been a XML representation for the LDAP protocol called DSML. Why did you use this one?
I don't know.
Any other questions? No? So, thank you.
My pleasure.
We now move on to provisioning. Is this on? Yep. And the next speaker is Aida Omerovic of Uninet, Norway. So, please.
Okay, thank you very much, Rika. Okay, hello everybody. Thank you very much for being here today. I am going to talk about design, surprisingly enough, design of an architecture for provisioning, which we have been working on for approximately a couple of years now. My objective today is basically to inspire you for reading a paper which is uploaded on the conference program, not to come with all the details. So I really hope to manage that. And I do hope you are going to enjoy the talk anyway. And please feel free to ask the questions during the presentation. I'll also try to finish a little bit earlier so we get some time for discussion in case you have some questions. I'm coming from the Norwegian airline Uninet, a subsidiary called Uninet FAS, working mostly on the application level, the administrative applications to the higher education sector. This talk is mostly about the middleware for integration and with focus on provisioning and identity management, but I'll also indicate some of the other functional areas of that one. So I'll come with some of the best practices, present some of the building blocks of the architecture. I'll also give you a small use case of one of the parts of at least one of the services. Make some conclusions and give you an opportunity to make a dialogue. A little bit about what we mostly work on. We are, as I said, a part of the NREN. We do focus on the integration, some development, contracting, deployment, and so on to the sector. The idea is to perform extensible initiatives which are too demanding for the individual organizations, but feasible and cost-effective with the joint effort and shared resources, which mostly results in significant savings, improvement of service level, and new use areas. So what is provisioning? I'm not familiar with the audience very much. I suppose you come from very different backgrounds. So provisioning, I would say, is an automated way of supplying data to the applications, mostly data about identities and users, the end users. Why do we do it? Why do we do this? Why do we do the provisioning? There are two ways of looking at it. Basically, the idea is we have to supply the data about the users because they're supposed to be authorized within the applications. And in most cases, external authentication is not sufficient. So either automatically or manually, we do have to authorize them. Another way of looking at it is that an automation of such a service is the only efficient, cost-effective, and dependable way of making the users collaborate with the systems, with each other, and of making the systems collaborate across each other. The setting in our case is cross-organizational. There is a set of large-scale software-intensive and security-critical systems which are operated at distributed environments on the applicational level. And there is a huge variation in the technologies among these applications. I'm going to come back to this background. So the idea is to achieve some synergies in terms of value chain improvement and new services from system interactions. To gain some added value by achieving the interdependencies and creating new services through the collaboration of the systems. Provisioning is one of these, one of the application areas. The result is a system of systems offering more than the sum of the individual applications. The figure here is supposed to illustrate the purpose of the architecture. On this one, we have abstracted away the internal services of the architecture and showing only how it relates to the surroundings. The idea is to distinguish between the right-hand side and the left-hand side of the architecture. On the left-hand side, we have the incoming interfaces, which are well-defined, which are standardized and documented, and which both the organizations and the applications providing the data can relate to. There is a limited number of these. On the right-hand side, however, we have the services and the interfaces which basically speak the language of the individual applications and the services. These applications, in our case, could be the system for student administration, the human resource system, procurement, accounting system. It can be archiving system, case management, and so on. The interfaces they're providing are proprietary. Normally, it is a problem because we can't make them standardized. So what the architecture does is to transform the interfaces from the incoming ones into the outgoing ones, make them compatible in terms of mechanisms for transformation, semantics, syntax, validation, and so on. There's also a number of internal services which I'm going to come back to, which are covered within the architecture during the transformation. Next, this figure is meant to illustrate the building blocks of the architecture. It will be too time-consuming to go through all of this, but the basic idea is that there is a framework which is the base for the entire architecture, and that one is giving the guidelines for example, which actions to undertake during each life cycle phase of the development of such a middleware, what resources to use, what roles the different stakeholders should play, what recommendations could be given for during each life cycle phase, and so on. Next is basically about how to achieve the proper transmission, how to secure it. And then as we move to the upper levels, we have the syntax and the semantics validations at both level, message level, for example, a collection of messages level, or the ones being directly connected to the applications. We have augmenting and the merging of the data within the messages with their additional data related to the electronic contracts, or with the metadata. We have processing and filtering, splitting of these, which we before we prepare them for the dissemination into the individual applications. Then the dissemination actually happens right next to the splitting, and on the top of it there are a number of indicators defined to be quantified during the monitoring. So monitoring, error handling, quality assurance is performed at all of these levels. And on the top of it, we have some definitions of the service level management, putting the requirements on the operational environment of the middleware. That is deduced from an analysis of the interdependencies of all the systems interacting. So not only this middleware, but also all the components of the applications around it interacting with the middleware itself. if you recall the first figure I showed, I said that what happens within the architecture is abstracted away. This one is supposed to illustrate what the data flow looks like within the architecture itself. So we have the incoming interfaces from the organizations providing the data or the applications doing the same. We have a receival service. Assume that the syntax checks are passed. Then we have the semantical evaluation and content management, for example, based on the business intelligence and so on. Then we merge these data with the additional data and metadata, and this is done upon some electronic agreements with each one of the organizations. This is followed by splitting, and splitting is done at two levels. The first one is on the organizational level, and the second one is on the application level. So the number of messages is multiplied by both of these. When this is done, an additional deviation check is performed to make sure that the difference between the current status of the same kind of data within the applications does not differ too much from the one waiting to be disseminated. If this is the case, some additional checks are performed just to make sure that there are no obvious errors within this one. And then the dissemination, the interfaces connecting the architecture to the individual services are called. So to make this one a little bit more illustrative, some functional examples. It could be the identity data. It could be the data about the organizational structure or the organizations related to the users being provisioned here. It could be, for example, data about their rights. It could be. We also have an example of provisioning the employees into the accounting system, which then are used for further accounting purposes. It could be some case management data and so on. What should also be really important is to make a consensus about the metadata and their meaning. And when this is done, we have the services for handling and mapping and dissemination of the metadata. I'm going to show an example of this later on. By having the design which opens the services for additional interfaces, we do achieve some optimization of the workflow. Because this way, when we are the ones doing the splitting of the messages, for example, and when we are the ones performing all these services on the messages, we do reduce the data flow, the amount of data flow. And this is also supposed to enhance the value chain, because there are some models behind this one which are optimized before the design is initiated. So some of the recommendations from the general experiences here. What you need to make sure is that you have proper models which cover the current needs, which cover the potential needs, which close the gap between the working processes and the data flow. When this is in place, you need to perform the risk analysis and simulation of the behavior of the system, so you can actually put the proper security measures into your architecture here. So the security measures are revealed upon the risk analysis and the models. Make sure that the models are analyzable, optimizable, and controllable in terms of both the current and potential needs. Next is when the simulation is ready, you can actually compare the behavior you are expecting with the observed one and see how they fit. And this also gives you an indication of, for example, dependability issues and so on. Upon each change of either the services within the architecture or the interfaces, you need to perform timely revision. And then documentation. The paper also suggests what documentation is required and what is recommended. What you definitely need to have is documentation of the prerequisites for security measures, including the risk analysis and models. And you also need to have the sufficient technical documentation which makes you able to perform the extensions of the services and the interfaces. Among the main quality criteria of the platform are interoperability, maintainability, and extensibility. These are achieved mainly through modularity of the platform itself and of the applications collaborating with this one. The quality is maintained through monitoring, and a number of metrics are deduced, which you also can find detailed descriptions of in the paper. Some of the general experiences. It turns out to be very beneficial to have full control over the integration architecture. This is because the time to perform fixes, extensions, and analyze certain situations is minimized when you have collected the competence of both the design of the architecture and the ones operating it. Another thing is, by having such a solution, such an intermediate link for orchestrating the messages, you also have consistent interfaces, both the incoming and the outgoing ones. You can easily maintain the interactions. You can make them reusable and portable, both the interfaces and the services, and you can actually optimize the data flow. Among the critical success factors, at least as we can see it at the moment, are the compliance to standards, the modularity, and the dynamic configuration. So only by having dynamic configuration, you are achieving a level of flexibility which makes you easily compatible with any changes of, for example, policies or semantic rules, new interfaces. You can easily switch the interacting applications, and in most cases you can only do changes on the configuration without actually having to do any further development. And of course, data quality shows to be both a challenge and a solution for many of the tasks here. Semantical validation of data flow, validation of syntax. They solve, for example, the data flow things. They give you the intelligence about the contents of the messages, and they let you embed some of the additional services when you have the proper consensus and when they are consistent among the organizations. A use scenario, how to approach this. I have put some examples from the service supplier point of view, from the institution point of view in relation to the service supplier, some of the steps to undergo. I don't think I'm going very much into detail of this, but this is at least how we have experienced the right approach should be organized. It is very important to have a controlled approach and not to deploy the services in a premature manner. We are talking a lot about identity management. Here is an example of how this process is, the process of provisioning is observed from both the organizational and the service provider point of view. In our case, for example, there are operational environments which are spread all around the country because most of them are outsourced on the application level. Some of them are the authoritative sources and others are the ones which have to be supplied by this data. And in some cases, the data flow is also two-way. So what happens is that we have distribution of the operational environments. We have a multitude of the messages in the data flow here, and an example is, for example, the human resource or student administrative system, which is providing the authoritative data into the user administration system. So if you can imagine the complexity, the human resource system delivers a number of messages. It is distant in a single operational environment. It provides these messages into the administration systems of each of the individual organizations. And the user administration system is located within the organizations. Then the data is processed within this one, and the user administration system relates to the provisioning architecture, which I'm talking about, normally in terms of only single messages. And then the dissemination is performed, as I described, in terms of a number of messages, as many as a multiplication of the organizations and the applications, which also are distributed. There is also an example of a schema. The reason why I wanted to mention this one is because it's based on the IMS standard. It is also a little bit adjusted to our special needs, mostly because we had to redefine some of the attributes within this one for our needs. I don't think I'm going into the details of the XML format of this one. There are some deviations, but those of you familiar with the IMS will probably recognize most of it. 5 minutes. This is an exemplar service for syntax and semantics validation. This is provided outside the architecture itself. It relates to the standardized interfaces, the incoming ones. There are service-specific rules for the semantics. It's easily configurable. These are dynamic. They're extensible, and they're defined on service level, mostly covering each one of the interfaces or the schema supported by the incoming interfaces or the architecture. The idea is to provide a service to the customer organizations and vendors during the validation and testing of their solutions. There is a multi-level checking and reporting meaning that you can do it both on the application level and on the message level. So what you can do is to build up a message containing all the data you intend to send into the applications, and you can run this semantics validator. The result would be, for example, comments on the contents of your data, warnings, some suggestions for improvements, or the errors. Errors are going to stop the data flow in the architecture in case they come out of this one. Some conclusions here. It turns out that centralized integration architecture is a necessity when enabling interactions between distributed applications with heterogeneous technologies or between distributed organizations. That is our general experience. You need to make a balance between the functional needs and the technical choices you make. And the architecture provides a toolbox. There are basically no guarantees of how dependable it is, but you can do some monitoring, you can do some quality checks, and you can use the appropriate tools depending on what the critical services you are trying to cover and what interdependencies you are expected to come in the future. So I think I'll stop here in case there are questions. Please go ahead.
Questions, please?
When you mention the deviation from IMS, that means that an IMS compliant application cannot work with your schema, or?
It will probably depend on how lucky you are. But the answer is not necessarily. There are some deviations on attribute level.
But very significant attributes, or it's?
Not really, not really. It's mostly about the way we interpret what they should contain.
Yeah. So it's a constraint. You have imposed constraints on the values. So
We haven't really imposed constraints, no. It's the deviation is mostly about how we expect the contents to be built. For example, this national ID which FADA is providing, it has a certain building structure. We do expect that one, and the semantics validator is going to check on that one. And in case IMS, for example, uses an attribute which doesn't necessarily impose requirements on that one, we do expect something like that. That's an example of this one, yeah.
Any more questions? So, thank you, Adam. And our last speak is about Shibboleth in the grids world and the project that Switch has had in integrating Shibboleth and G-Lite. And we have Christopher Witzig as the speaker. Christopher, please, the floor is yours.
Okay, thank you. Hello, everybody. The topic of my talk is the interoperability of Shibboleth and G-Lite. And I'd like to point out I really stick to the narrow definition of this talk. That means when I talk about grids, I primarily mean G-Lite. And when I talk about AAI, I primarily mean Shibboleth. The work is done within the context of EG project funded by the EU. So this is the outlook, the content of my presentation. I have a rather lengthy introduction in which we first look at the motivation why we want to have interoperability between Shibboleth and grids. We then look at the authentication and authorization techniques that are used in grids and shibboleths and contrast the two towards each other to see what are the main factors here. And then based on that, I give you the broad outline of our work within the EGE2 collaboration. The work is divided in 3 phases. In the next 2 sections of my talk, I describe the individual phases. First, phase 1, which is a short-lived credential service, and phase 2, in which we transfer attributes from shibboleth into WOMs. I explain these expressions as we go along. And finally, at the end, I give an outlook on the 3rd phase of our work. And as well, I mentioned a few other activities that are active in this area. So why would we want to have interoperability of shibboleth and grids? Well, obviously for AAI federations, the main motivation is clear. You add more resources, which is something that you aim for. That's one of the main goals of federations. And for grids, of course, it's very interesting because it opens up to them a whole new user base. Grids primarily have been focused on small user communities. They have techniques, as we will see later on, PKI techniques, in which they give users certificates, which is a very time-consuming step and a hurdle for many users. Connecting to shibboleth, meaning connecting to the campus networks, has a potential of broadening the user base to an extent that's barely possible with the common techniques. However, there's other factors one has to look on. First of all, for the users, for the user, of course, it has the benefit that he will have simpler management of his credentials. One of the main goals of shibboleth is that the user has one set of credentials that he can use on many resources, and obviously a grid resource, if you add a grid resource to that, that's a gain for the user, and it also gives the user easier access to grids. And for the e-signs as such, it has the advantage of having a unified user base, plus it brings stakeholders together. Often these AAI infrastructures are being built through NRENs like Switch, whereas the grid world has been built up using another community. So I now come to the second part of my introduction, in which I'd like to show you a little bit the difference between the shibboleth techniques and the grid way of authorization and authentication users. The various technologies in use in AAIs, ultimately we want to control access to resources. I distinguish here 2 models. One is what I call the passport models, which is of course the PKI model for grids, and the other one is the federated identity model used in shibboleth. Now, how does the passport model look like? Why it's a passport model? It's basically a user is giving a piece of data, a passport or a long-term certificate. And with this long-term certificate, he wants to access grid resources. In addition, in grid, there's, besides the long-term credential, there's always the membership in a virtual organization which spans many institutions. And I will now look at the use case of job submission, where a user wants to submit a job to a resource broker, and I depict in my talk secure services through castles. So obviously what he has to do is he has to submit a job, and in addition to the job, he submits his credential. So the credential wanders with him to the resource. And actually it's a little bit more trickier in the sense that he does not submit his long-term credential, his long-term certificate. What he submits is a proxy certificate that he produced. And in addition, in the proxy certificate, he adds a little bit of data coming from his virtual organization. So that little data is from the virtual organization is embedded in an attribute certificate in WOMS, which is the VO management system that EG uses. Now the resource broker, obviously he authenticates and he authorizes the user base on that proxy certificate. Next, something very interesting happens, namely now the resource broker wants to act on behalf of the user and sends his job together with yet another proxy certificate to the computing element, which ultimately corresponds to a site. That's where his job is supposed to run, somewhere on a cluster, on a local resource management system. So this step is called delegation. So obviously that's deeply embedded in grids. And of course, what the computing element does is exactly the same. The computing element looks for a worker node where the job can execute. And of course, that involves yet another creation of another proxy certificate. So these certificates, they basically clutter throughout the entire middleware stack of grid software. And obviously, if you want to talk about interoperability of Shibboleth with grid software, then you see that you have a rather formidable task. How does the federated identity model look like in Shibboleth? The use case that I look at here is, again, a user wants to access a resource, or in Shibboleth language, it's called a service provider, which is depicted through this castle symbolizing the secure service. Now, what happens here is something very different than in the grid use case. What happens, namely, is that the federated identity model gives the user so-called a hometown or home organization or identity provider. And this is where the user authenticates himself. So the authentication step is always going to the same place, his home organization. And the home organization then sends some information in a language called SAML to the service provider. And the service provider authorizes the user based on the information that he gets from this home organization. So that's the basic mechanism in a nutshell that Shibboleth is structured on. So you see it's very different than in the grid world. And in particular, one thing that's also different is then the service provider that has received this data from the home organization authorizes the user what shall he do in order to involve yet another element, meaning the delegation step that I described before. So obviously in this model, this step is not clearly defined, or you have to define it for yourself. So what are the sort of main topics that I touched in the last two slides? First of all, in grid resources, you have an authentication step at the resource, whereas in Shibboleth, that's factored out to a home organization or identity provider. And obviously, that's a very powerful concept, because in grids, you now have basically every grid service anywhere in the stack is looking for a certificate trying to authenticate the user. The second concept that I mentioned is the attribute-based authorization that Shibboleth implements very elegantly, and which is also partly available in grid through those attribute certificates that sits in a proxy certificate. And that immediately leads to the next question, namely, you now have attributes coming from this virtual organization, as well as attributes coming from the home organization. How should these attributes relate to each other? I mentioned the importance of the delegation step in grid, and one thing that I didn't mention yet is that these proxy certificates are rather short-lived. They expire, they have to be renewed. How would you want to have a renewal of a SAML assertion? That's another topic. So you see there's a whole can of worms here. Now, what we have decided early on in this project, EGE is a 2-year project, that obviously you can't do everything. So we decided that in the first phase, which should span the first year, we try in 2 steps, in a phase 1 and a phase 2, to add interoperability on a small scale with very modest means, in the sense that one has a working system. And then in the second year, which is now about to start, that we will add SAML to some selected grid services. There will also be a continuation of EGE, if approved, where we will continue this third phase. So how is the overview of this phase 1 and phase 2? I show you here the picture of a grid user, as it's currently the case within EGE. He has his long-term certificate, as I explained, and he has this membership in this virtual organization, which is being provided by the software tool VOMS, and that gives him the proxy certificate. So our first phase is very simple. We want to replace the long-term certificate we develop a shibboleth service provider, shown in blue, upon which gives this user a certificate based on authentication at the shibboleth identity provider. So that's the first phase. That's called the short-lived credential service. And the second phase is yet the development of another service provider, shibboleth service provider, which allows the user to transfer attributes from his identity provider, from his home organization, into WOMs. And with this mechanism that I described earlier, these attributes will then become part of the attribute certificate that is embedded in the proxy certificate that the user uses to communicate with the grid services. So you see, all those grid services here, they're basically untouched. And that was our main intention for this for this phase 1 and phase 2. We also took a few design decisions. First of all, we wanted those two service providers to be independent of each other. That should mean they're independent service providers for shibboleth's point of view, and it should also be possible to deploy them separately. In addition, we wanted to make sure that the first service provider, the SlickCA, is independent of the grid middleware, meaning it should be independent for G-Lite, such that if other people want to use it, they can use it. And for the second service provider, it should only be dependent on WOMs. So now let's look at this first service provider, this phase 1, this short-lived credential service. And you see the cartoon here. The idea is, as I just said, that the researcher uses his normal AAI credential, his shibboleth credential, to authenticate to his shibboleth identity provider, and magically a certificate slides onto his computer and ends up in the right directory from where he executes the grid software. Now, what are these SLIC certificates? These SLIC certificates, they implement a profile that has been formulated by the International Grid Trust Federation. It has a few requirements, and the three most important requirements are listed here. First of all, the certificate is generated out of an identity management system. Second, it has a short lifetime, meaning less than 1 million seconds, which is about 11 days. And third, the revocation handling, because of its short lifetime, is optional. How does the operation look like of this service from the user's point of view? It's a command line tool. It will be as part of the next release of the G-Lite software. That means on the G-Lite software, it's called the user interface, but it's not a graphical user interface. It's basically the machine from which the user executes or sends his jobs. So it'll be installed there, and of course it can be installed separately. It's written in Java. But for the user, in the sense, the whole mechanism is invisible. He just executes this tool on the command line. He's being asked for his password, and he gets a certificate. In addition, this service has also a web-based administrator tool, because the user has to go through a short registration step, because often these identity management systems have several classes of accounts, and that way we can guarantee that really only properly or verified accounts can use this feature and obtain a certificate. And of course, a shibboleth identity manager can also see how this tool is used for his users. And the service itself is operated by Switch. How does it work? I'm not going to go here through the entire detail of steps, but the client agent, the user agent here on the command line, it basically goes through the standard shibboleth handshake mechanism. It creates a key pair. It then sends a CSR to the SLIC service. The SLIC service then talks to a backend CA and receives the certificate, which is being pushed on to the client's desktop machine, from where it's then available. What is important is that the private key is never transferred over the network. It really resides on the client's machine. We tried to use only standard protocols in the system, and particularly here. And so it's fairly easy to exchange the CA. We use the Microsoft CA, but if you implement the right interface, then you can plug in another CA here as well. And we also try to make the code as modular as possible, such that people can modify it according to their needs. And most classes are loaded, are configured through XML files and can be changed on the fly. One other thing that I should mention, the shibboleth attributes here, they're used to determine the DN of the certificate. And that's also a class that somebody can easily change if he chooses to do so. The status of this service, the software development has been finished last year, and it has been accredited by the EU GRID PMA. Why did we want to have this accreditation step? Simply because that way a Swiss scientist that obtains the certificate can really use it on standard GRID installations. So in EGE, this certificate, because the CA has been accredited by EU GRID PMA, can be used on, for instance, the LHC computing grid or other grids that span multiple nations. That has been a very important feature for us, but also it has meant quite a lot of work. The service has just become operational, and you find here the URL where you can get more information on this service. So that has been this first phase, which we now basically finished the development and we're in operation. Now I talk about the second phase, in which we want to exchange those VOMs those shibboleth attributes into VOMs to make them available to GRID resources. So the problem, as I mentioned before, phase one deals with the authentication of the user and giving the user a short-lived credential. Phase two makes these attributes, these shibboleth attributes, available to GRID resources. And of course, the couple of questions that you have is, which AAI attributes are really relevant for GRID resources? Second is, how shall the GRID resource obtain those attributes? There's two models. One model is that the user submits, together with his information, his job, also those attributes, which is the push model, or should the resource pull those models off the shibboleth identity provider? We decided early on to use the push model, meaning the attributes come along to the GRID resource. The GRID resource does not have to go out and get it, because we feel that introduces a fair number of overhead, particularly given the large installation base of LCG. Then, of course, the other question is, how should these attributes coming from the IDP relate to the VO attributes? And there are deployment issues. As this software should be deployed on existing GRID middlewares, obviously we don't want to break things, or we make ourselves extremely popular if we do. So, these shibboleth attributes, one important thing to remember, this work has been done within the Switch AAI Federation. That means for us, the meaning of those attributes is clear, but if you go for inter-federation access, then obviously these attributes' meaning is less clear. In Switch AAI, these attributes are derived from EduPerson, and the sort of attributes that are relevant for us is really a very small subset. It's basically, where is the user, what is the identity provider of the user, what is his study branch, his study information, or does he have a staff status, and whether he's member of any particular groups. That's the sort of information that we put out towards GRID resources. The design of the service, as I mentioned in the introduction, it's a shibboleth service provider. That means it's a browser-based tool here. And it's specific. There's one instance per federation per VO, which is shown here. So the user wants to be member of two VOs, one an A and B. If he wants to get his shibboleth attributes onto one of those VOs, he has to access with his browser this service. There, after the standard shibboleth handshake, he will get the information of the attributes that will be transferred, and he has to give his explicit approval by pressing a button. That was important for data privacy reasons. The service provider here, another design goal was these should be very lightweight service providers, meaning There should be any administration on it, so no administrative duties for someone. It shouldn't be any management of attributes, simply a transferal. And in particular, it shouldn't interfere in any way with any registration software that some people may have already installed on top of WOMS, like WOMS RS or whatever people are using. In addition, the attributes should not be changed, meaning once these attributes are in WOMS, they will be treated like a WOMS attributes. The VO registration is not changed, as I mentioned, and that way the administrative domains of the Shibboleth IDP and of the VO using WOMS are completely decoupled. We felt that was very important. The user also, if he's member under several DNs, he can choose to which DN he makes the mapping. And finally, in the end, once people have used this tool, it'll become a lookup service between the Shibboleth user ID and the user's DN as registered in WOMS. Here you see the web interface service where the values on WOMS are shown or nothing if they have never been transferred, and here you see information of the user and the button that the user has to press. What is the status of this service? The software implementation is done. We have also documentation. It was a milestone. And currently we're now completing the step in the sense that we now have to write some plugins that grab those attributes at the grid resource out of the proxy certificates, evaluate them, and then authorize the user. And that's being done first through the modules LCAS and LC maps. Now I have a few minutes left, so I give you the introduction, what we're going to do in the third phase. As I mentioned in the beginning, the main goal of the third phase is to expand the use of SAML beyond what we have in phase 1 and 2. Remember, in phase 1 and 2, we're basically not touching the grid services. In phase 3, we would like to SAML enable those grid services with which the user directly interacts. We see the following benefits in it. First of all, it will allow the average user, and in particular if one has in mind that one wants in the long run enable the grid to a large user community which should just use the grid because it's there, not because he understands it, then obviously that average user will no longer need certificates. We think that's a very big benefit. In addition, it also allows us to introduce the SAML technology in a more gentle way into the grid. And it also means, because one only deals with a limited number of services, that one introduces this SAML in a rather gentle way and into the grid software, and that's also very good for production grids. In addition, this approach is compatible with what the Shibboleth team is doing. I mean, Shibboleth 2.0 is just about now to come out. Many of the things that one wants to do, like delegation, is something that now exists, a spec with IDWSF. But by the time that's in Shibboleth, we talk, it'll take some time. So this timeline allows us to march in step with Shibboleth deployments and capabilities that being added into release 2.1 and beyond. And it also, of course, gives us the options to the future. Now, before closing, I'd like to mention a few other efforts. The switch effort is in no way the only one in this area. The one that probably most people have heard of is the GridShip project in the US. It's focused on the Globus infrastructure. They developed plugin modules for Globus as well as for the IDP, which was something that we purposely didn't want to do. But they developed these plugin modules that allows the grid resources to pull the attributes out of Shibboleth directly. They're now working on portals such that they want to, within the TerraGrid installation, they want to make TerraGrid available through community portals to a large user base. That's basically the program for this year. There's also a fair amount of activity in the UK, given their large grid deployment and now their huge effort into Shibboleth. Two projects that just finished are the Shibangs and the ShipGrid project. And one thing that I'd like to mention, which is one thing I didn't really touch on the talk, is there's also a project which deals with attribute aggregation from multiple IDPs. And these IDPs could, for instance, be one the user's home organization and the other one WOMS, which is being enabled to also deliver SAML assertions. That's part of the OMA Europe EU project. So my summary, I described briefly in phase 1. We have this SLIC service. It's an online CA. It's EU Grid PMA accredited. And it gives the user a short-lived credential, short-lived certificate based on his authentication at the Shibboleth service provider. And this is now finished and it's in production mode. The second phase, which we called WASH, I didn't mention that word, it stands for WOMS attributes from Shibboleth. It transfers Shibboleth attributes from the IDP into WOMS. These SHIB attributes are afterwards available to grid resources as part of the WOMS attribute certificate. And the software development is there finished. We're now working on plugin modules that allow authorization decisions based on these attributes at the grid resource. And on phase 3, that's just something which we are about to start now. It will keep us busy for the second year of EGE2. And if the project is approved, we will carry on that work in EGE3. And here the idea is to SAML enable a small number of key grid services, namely the ones with which the user directly interacts most often. Thank you, and if you have any questions, I'm happy to answer them.
Any questions? We have some time left.
It's mainly about the SLCS. You're using an online CA which is homegrown, it's commercial.
Aha. Well, let's maybe go back to the slide. It's actually, this slide does not show the real hardware layout. This service provider is actually the Shibboleth service provider and the online CA are distributed over 3 servers. On the first server is just, the Apache front end talking through mod GK to Tomcat, to the actual SHIB web app on the middle part. The front end is in the DMC and the SHIB web app is in a secure internal network. And the online CA, that's, as I mentioned, it's a Microsoft certificate service that runs on the window on a dedicated network. So we have an increasingly tighter security scheme around those 3 boxes. And of course, the reason why we did that is simply because we wanted to get accredited. I think if you could, in principle, you can basically set all that software up on one machine if you choose so. But then obviously you have a much harder time to convince people that you're really operating a production quality PKI service. But it can be done on one machine, that's fine.
No, I was thinking about, during the DAME project, inside the DAME project, there is some discussion about something they call the, what's the name, the credential conversion service. This sounds like a case of a credential conversion services. So we in fact, we're thinking about, it could be extensible to some other federations. I was curious about how you made this.
Well, actually, as part of this phase 3, what we will have to develop there, I mentioned that we are aiming at SAML enabling the front layer services for the user. So behind that, you also would need a credential translation service. So, yeah.
Any other questions?
Is the software available?
Yes? Yes?
Open? Free?
Open, free.
Cool.
You can download it. So you can get it either. You can get it either. Well, the most natural place to get it is off the CERN G-Lite distribution. But we're happy to help whoever wants to download it and try it out or install it in a production environment. Of course, we're happy to help.
Thanks. It's actually a question I think I've answered by looking at the CPS online, but one of the issues we've had is, sorry, Andrew Cormack from UKERNA, so see the previous UK slide. One of the issues we've had is the different level of authentication that the grid community and the shibboleth community sort of regard as normal business. From your CPS, I see that it's up to the individual RA to say, yes, that user's shibboleth credential was issued up to grid standard, if I've understood correctly. So you're actually, if you like, doing level of authentication out of band in that sense, rather than trying to build it into SHIB, because that's something we're sort of staring at and trying to scratch our heads and work out how many levels of authentication there is. But yeah, am I correct in my interpretation of what you're doing at the moment?
And what was the question? Okay.
Am I right that you're doing level of authentication by getting the RA to look at each individual user and say, yes, your SHIB credential is good enough?
Well, what we have is actually in our CPCPS, we formulated a set of criteria that a user account has to fulfill in order to use this service. Now, what this person, and obviously those shibboleth accounts, they're being created in different ways. Between different identity providers may have different internal processes to deliver their accounts to the users. So obviously we didn't want to tell people that's a good account and that's a bad account. But we wanted to tell them this is an account that can use this service. So we have a set of conditions. And then it's up to the people that run the IDP that really know, based on which criteria this account was created. They can then decide this guy has access to the service or he shouldn't have. They can also decide that entire groups of accounts fulfill these requirements. And that way they can basically open up this service to a group of people. I give you an example. I mean, an identity provider may have internal procedures for giving accounts to postdocs. And if these procedures fulfill our requirements, they can basically open up this service to all postdocs. And of course, they may also have a couple of guest accounts, for instance. I don't know whether people have that, but in case they do have it, then obviously these test accounts should not fulfill these requirements. So the test accounts should not be given access to this service. So that's the main idea here.
Any more questions? So thank you, Christopher.